Imagine a robot so lifelike, it could actually learn your job just by watching you work.
Yeah.
And what if it could even, pick up on your subtle emotional cues, reacting to your mood without a single command?
Sounds like pure science fiction, doesn't it?
It really does. But, well, today we're doing a deep dive into something pretty concrete. Two fascinating patent documents. We've got US 11112781 and US 9676098.
And the fact they're patents is key here. This isn't just theory. It signals, serious intent for actual real-world stuff.
Exactly. So what these patents really do is lay out this detailed framework for creating machines, machines that can mimic human actions.
And maybe even mimic some aspects of our, subjective emotional states, which is where it gets really interesting.
Absolutely. So our mission today really is to explore the big questions these things raise.
Like, can these technologies actually lay the groundwork for human-level intelligence? Maybe even something approaching machine consciousness.
That's the big one. And sort of following from that, how close are we, realistically, to seeing humanoid robots becoming, a seamless part of our workforce?
Potentially as direct drop-in replacements for human labor. That's the million-dollar question, isn't it?
It really is. Profound questions. They get right to the heart of what these patents seem to be aiming for. So let's start at the beginning. How do these robots actually learn from life?
Okay.
What's the core idea, the mechanism that lets them mimic us so closely?
So the fundamental concept they describe is called behavior capture. Basically, autonomous robots are trained by collecting just incredibly detailed sensor data.
From living subjects.
Right, from living subjects, humans, could even be animals as they just go about performing tasks in their normal environments.
So think of it like direct imitation, but supercharged with data.
Exactly. Direct imitation on a massive data-driven scale. Almost total imitation, potentially.
Oh, wow. Direct imitation. That's a powerful idea. And okay, to do this, the patents talk about something pretty unique. A behavior capture suit.
Ah, yes, the suit.
I'm picturing something straight out of sci-fi, like you said. Yeah. Can you describe this thing, this garment, and the sensors it's packed with? It sounds comprehensive.
It definitely evokes that image. The patents detail a snug-fitting jumpsuit-style garment that the subject wears.
Not fitting, okay.
And yeah, it's absolutely bristling with sensors. We're talking multi-axis accelerometers.
For what, like tilt and motion?
Exactly. Tilt, orientation, motion, capturing everything from gravity to the most subtle little shifts in movement. Then you've got bend and pressure sensors.
To detect flexing and stretching.
Right. Flexing of limbs, stretching of skin, plus microphones for audio capture and video cameras' stereoscopic views even.
So it gets depth perception like we do?
Precisely. And beyond that, they even include environmental sensors. Things like temperature, humidity, barometric pressure.
Wow. Okay, so it's not just capturing the big movements. It's this incredibly rich tapestry of data.
Totally.
You're getting everything from changes in posture, changes in position, vocalizations, gestures, grasping, gait, all these bodily dynamics.
And all alongside real-time video and audio of what's happening around the subject.
That is a truly immense amount of information to feed into a machine.
It is. And here's where the ambition really, really becomes clear.
Go on.
The ultimate goal for the robot's physical structure, its body, is to be so similar to the human subject's body.
How similar?
We're talking same shape, same degrees of freedom in the limbs, all of that. So similar that if they were both wearing the same outer covering...
Like clothes or the suit?
Yeah, the human in the garment and corresponding robot would be, and this is a quote, visually indistinguishable to a casual observer.
Visually indistinguishable. That is audacious.
Yeah.
That goal right there speaks volumes about the replacement idea, doesn't it?
It really does. It suggests they're not just aiming for a tool, but something that can occupy the same physical space, perform the same actions in a way that blends in seamlessly.
Okay, visually indistinguishable. Let's hold on to that thought. So once all this incredibly rich, multimodal data is captured, how does the robot actually process it? How does it turn observation into action?
Right.
What's going on inside the robot's brain, so to speak?
So this vast amount of sensor data gets fed into a machine learning algorithm. Primarily, they talk about artificial neural networks, ANNs, or sometimes recurrent neural networks, RNNs.
Okay, neural nets.
Yeah.
Like the AI systems we hear so much about.
Exactly. Think of them as complex computer programs that learn from data. They're loosely inspired by how our brains work, designed to recognize patterns and, crucially, make decisions based on those patterns.
So that's the robot's brain learning how to behave.
Essentially, yes.
So if I'm getting this right,
yeah,
The sensor data is the input, what the robot observes. Let's call it X.
Yep.
And the neural network crunches that X to generate precise control signals, Y, for its effectors.
Exactly.
And effectors are like the robot's muscles and voice, motors, actuators, audio devices.
You got it. Motors, actuators, audio generation devices, all that. It's a continuous loop. Input X, computation by the ANN, output Y, controlling the effectors.
And it sounds like it needs to be incredibly fast to look natural.
Oh, absolutely. For smooth, natural movement that actually mirrors human fluidity, this processing has to be remarkably rapid.
How rapid?
The system aims to figure out these control signals tens, hundreds, thousands, or even more time intervals per second.
Wow. Per second.
Yeah, that's what ensures that seamless, natural flow we see in human actions, you know? Not jerky, obviously robotic movements.
Okay, but how does a robot start? An untrained robot?
Mm-hmm.
Can't just perfectly mimic from day one, right?
No, definitely not.
Just flail around. There must be some starting point before it learns from the real human data.
You're right. It's an iterative process. Training involves refinement. So initially, the ANN is indeed untrained. Blank slate, basically.
Yep.
It starts by generating what the patents call bootstrapping data. This is where software tools essentially directly drive the robot through a whole range of motions.
Sounds like puppeteering it.
Sort of, yeah. These initial movements might be clunky, maybe unnatural, but they create a foundational set of input-output examples. X causes Y. It gives the neural network something to start learning from.
Right, a baseline. But what's the breakthrough then? What makes it actually natural? Because that bootstrapping sounds pretty crude.
It is a starting point.
How does the data from actual living subjects transform this?
Well, that's where the real magic happens, as they say. Once that initial, maybe clunky training is done.
Yeah.
The detailed sensor data captured from actual living subjects performing the same task gets fed into the robot's ANN. That is the crucial step.
Why is it so crucial?
Because it allows the robot to generate much more natural movements. It's iterative, like I said. The system constantly compares the robot's generated movements to the real human data.
And adjusts itself.
Exactly. It keeps tweaking its internal model based on the human examples. This cycle allows for continuous improvement, and gradually, much more sophisticated, lifelike actions start to emerge.
Okay, that makes sense. It's learning from the master, essentially. But it goes even further, right? The patents mention secondary ANNs.
They do.
What are those about? Are they trying to add some kind of feeling or understanding?
Right.
Moving beyond just copying movements.
This is where it touches on those deeper questions about intelligence, maybe even consciousness. These secondary ANNs are designed to model physiological signals from the living subject.
Physiological signals? Like what?
Things like electrocardiography, EKG, electroencephalography, EEG, or respiratory measurements, heart rate, brain waves, breathing patterns.
Wow. Okay, so it's capturing the human's internal state, too.
It's modeling it, yes. And these signals are then used, and this is fascinating, to encode some aspect of the living subject's subjective emotional state.
Encode?
Yeah.
The emotional state.
Yeah. Which allows the robot to be configured to express emotional nuance in its behavior similar to that of the living subject.
Hold on. A robot that can not only move like you, but also express emotions like you, based on your own EKG or EEG data.
That's what the patent describes.
That's a staggering leap. That feels much closer to what we might perceive as human-level intelligence, or at least a convincing simulation of it. Does it feel anything? Or just express?
The patents don't claim it feels. It's about expression based on correlating physiological data with behavior, but the effect on an observer could be profound.
I'll say. And it doesn't stop there. They mention simulating inner dialogue or complementary imagery, connecting to the internet.
Right. The secondary ANNs could potentially simulate these internal states, maybe curated by designers, or draw on external data. And the patent explicitly states something really key here.
What's that?
It says this intimate combination of body-centric and environment-centric data forms the basis for the emergence of intelligent-seeming behavior.
Intelligent-seeming behavior, okay.
It's about combining these internal state models, even simulated ones, with the external observations to create what appears to us as intelligent, nuanced responses.
So even if the robot isn't conscious, if it can express emotions convincingly based on human physiological input, that fundamentally shifts how we might perceive intelligent interaction, right?
Absolutely. It blurs the lines in a very significant way.
Okay, let's make this more concrete. There's a specific example in the patents. The barista. Let's talk about that.
Right, the barista example, it's a good one.
So, Picture a really skilled barista, top of their game. They wear the sensor suit while working in a busy cafe.
During real work hours, dealing with everything that involves.
Demanding customers, making complex drinks, handling unexpected rushes, maybe even, I don't know, calming down someone who's frustrated.
Exactly. The goal isn't just to capture the steps of making a latte. It's the full spectrum of her human behavior.
So how she adapts, how she problem solves on the fly, manages interactions.
Precisely. It's about capturing the complex, varied, yet often reproducible and consistent aspects of the job, including dealing with unexpected circumstances, the whole package.
And the objective for the robot
Is to exhibit the human barista's skills to the greatest possible extent, to essentially become that skilled barista, behaviorally speaking.
Okay, so connecting this back.
Yeah.
What does this all mean for the big dream of artificial general intelligence, AGI? The patents seem quite bold here.
They are. They suggest that with, and this is a caveat, sufficiently powerful hardware.
Right, the hardware needs to keep up.
Then, some semblance of intelligent and articulate use of language, proficiency in the physical skills, and practical problem-solving strategies can emerge in the robot.
A semblance of it emerging just from this process.
That's the claim.
Yeah.
And they go further. They state that training with data from numerous living subjects, especially expert.
Cooling expertise.
Exactly. Could lead to a machine learning program instance that, quote, for practical purposes is equal to or greater than that of any single living subject that contributed to its training example repository.
Whoa. Better than any individual human trainer.
That's the implication. And then they drop the term. Such a machine learning program instance constitutes an artificial general intelligence.
They actually use the term AGI.
They do. And what's really insightful, I think, is that this proposes a specific path to AGI. It's not just about feeding massive text data sets into a model.
It's embodied, learning in the real world.
Exactly. Embodied real-world learning. The idea that a robot learning through direct physical experience, even mimicking human physiology via those secondary ANNs, that might unlock intelligence in ways purely abstract models haven't. It feels like a foundational shift in how we might build AGI.
That is an incredible statement. An AGI, potentially surpassing human experts, built through observation and interaction. And it's not just baristas, is it? The range of applications seems huge.
Oh, it's vast. The patents mention roles across many sectors. Think elder care, nursing, housemaids, general retail and food service tasks, information kiosk attendants, receptionists, security, and surveillance.
So many service industry and care roles.
Yes, and even companionship and loneliness mitigation, which taps right back into that emotional expression capability.
Companionship bots.
Okay. And they also mentioned training specialized service robots, or even robotic beasts of burden using animal subjects.
Training robots based on animal movements for specific tasks.
Yeah, opens up whole new categories of autonomous machines for maybe agriculture, logistics, construction,
Right.
physically demanding roles.
Okay, so let's bring it back to the labor question. We have to tackle this head on.
Right.
With this level of potential sophistication learning complex tasks, adapting, expressing emotional nuance, maybe even achieving AGI, are humanoid robot drop-in replacements really on the horizon? Is that the end game here?
Well, the ultimate goal outlined in the patents is pretty clear. Continuous, unsupervised operation of the autonomous robot.
Unsupervised, meaning it works on its own.
Exactly. Operating where it behaves very much like the subject did in the setting where the behavior capture sessions were carried out.
That sounds exactly like a replacement, doesn't it?
It points directly towards a future where these robots operate independently in roles humans currently fill. The aim seems to be seamless integration into workplaces.
But hang on, this isn't instantaneous, is it? The barista example. They said that project might last months or years.
That's a really critical point, yes.
That sounds like a massive undertaking, not something you just switch on overnight.
Absolutely not. Achieving that human-level competency, especially in a complex, dynamic role like a barista, it requires an enormous scale of data collection and that iterative refinement we talked about. It's a long haul.
So while the goal might be to have the robot carry out the duties of a human barista to a level acceptable and keep learning, it takes significant time and effort to get there.
It does, however, and this is the really profound bit for the labor question, the patents explicitly mention the ability to reproduce an AGI.
Once you've trained it.
Once you've achieved that high level of competence, potentially AGI, you can reproduce it in an unlimited number of autonomous robots.
So train one expert robot brain,
and then copy it endlessly. One expertly trained brain could power an entire fleet. That's how you scale human-like capability far beyond what individual human training could ever achieve. That's the disruptive potential for labor markets.
Okay. Wow. So let's try and recap this. It's an incredibly ambitious vision we've unpacked here.
Definitely.
A system designed to teach robots human-level behaviors, including subtle things like emotional nuance, maybe even reaching AGI.
All simply by observing us, using these sophisticated sensor suits.
Right. And this method aims to create robots that aren't just good at tasks, but are quite literally, visually and behaviorally, almost indistinguishable from humans in their movements, their expressions.
Even mimicking physiological signals to inform that expression.
Yeah. It's this systematic capture of multimodal, data, body-centric, environment-centric, combined with that iterative neural network training.
And that's presented as the pathway to these highly capable autonomous systems, which, as we've discussed, has profound implications for how we define intelligence and maybe even consciousness in machines.
Especially when they can simulate emotions and perform complex tasks potentially, as well as, or maybe even better than, human experts.
Precisely.
So this really raises a huge final question for you, the listener, to think about. If a robot can learn to be an expert barista or a compassionate nurse, or even just a nuanced companion.
Trained to be practically indistinguishable from a human.
Right. What does that actually mean for how we define intelligence, or empathy, or the very nature of work itself?
And maybe what new roles open up for humans? Are we becoming trainers, curators, the original subjects for these AI? What's our place in this evolving dance between, carbon and silicon?